There we go. All right, so typically we don't want to leave negative exponents in our answers. So what we're going to go over today is how to get rid of the negative exponents. So the easiest way to do that is with an example. So let's say we have 3x to the negative 2, y to the 4th over c to the negative 3rd z. So anything that has a positive exponent is going to stay where it is, because that's fine. It's a positive exponent. It doesn't need to go anywhere. Right, so y to the 4th has a positive exponent, and our z does. So those are just going to stay where they are. But things that have negative exponents, so our x squared and our c, or x to the negative 2 and c to the negative 3, to make those positive, you're going to move them to the other side of the fraction. So our c, and then make it positive. So the c is going to go up, and the x is going to come down. So then when we write that, we're going to have 3, and then our c is going to come up and then change to positive. So you bring it to the opposite side of the fraction and you drop the negative. And then the y to the 4th stayed where it was. And then on the bottom, we're bringing the x down, making our 2 positive, and then the z stays where it is. Does that kind of make sense? Yes? Your face says no, your mouth says yes.
I don't understand how it works. It's like, it's not that I don't understand how to do it, it's just that I'm having trouble wrapping my head around, like, how that's even something that you can do.
So it's really because if you think anything to like, so x to the negative 1 is like the same as 1 over x. It's that negative exponent means you're taking the reciprocal. So technically you're just flipping it. So if you look like even on the calculator, your reciprocal button is, oh, there's not actually one in here. Oh, this one has it as 1 over x. But a lot of calculators, they have it as x to the negative 1. And what that does is it flips it. Because it's like inverting it. Because that's also, we use that negative 1 exponent when we start talking about like inverse of functions and things. So that's what that means. So you're just taking the reciprocal of it.
What would you do if it wasn't a fraction? Like if
You would make it into 1. So that's a good question. So if it's just like x to the negative 2. So if it's something like that, you just write that as 1 over x squared. You put that 1 in as kind of like a placeholder for your numerator. Or if you had, say, a coefficient in front of it. So if you had like 2x to the negative 3, you would just leave that 2 on the top part, but then move the x cubed down below it. Good question. All right. Any questions so far with negative exponents? Because that's really all there is to that. All right, so then the last thing I want to talk about is evaluating expressions. So that's kind of where you take an expression that's got lots of variables and things in it, and you're plugging in a specific value for that variable. So for example, let's say we have this expression of w to the 3rd minus 4w times w plus 2. All right, and if I ask you to, or the book or anything, ask you to evaluate that, it's going to tell you to evaluate it for a specific value of w. So it would say like, evaluate when w is equal to 3. So what that means is you're going to replace all those w's with 3's and then use your order of operations to simplify it to a number. So we're going to take all of our w's and change them to 3's. So you're going to have 3 to the third minus 4 times 3 times 3 plus 2. So, typically, just so you guys, I hate doing dots for multiplications in the middle of stuff because sometimes they're hard to see. So I typically just like put things in parentheses like beside each other to show multiplication, just so you guys know. Like I'll do the dots if it's already there in the book, but that's typically what I do to show where I plug stuff in like that. All right, so then we use order of operations, right? So we're going to do our 3 plus 2 first. So 3 to the third minus 4 times 3. And then 3 plus 2 is going to give us 5. Then we do our exponent of 3. So 3 to the third is 27. All right, and then we've got that multiplication of 4 times 3 times 5. So I would just multiply those 3 kind of all at once. And that's going to give you 60. So you get 27 minus 60, which is going to be equal to negative 33. You guys have done this before, right? Okay. So it's basically another order of operations problem. You just have to plug the numbers in yourself. Okay, so that really sums up the notes that we needed to do today. Any questions with evaluating expressions? Do we feel fairly okay about that? Kind of, sort of, at least for now anyway. All right, so your assignment